Okay, just a little reminder, yes, this is the product rule. And then I think it was Aaron, you mentioned we needed to use the chain rule because inside this derivative we've got a composite function. So let's see, we've got x and then we've got something to the 1/3 power, so it's 1/3 that something to the negative 2/3 power. Then the derivative with respect to x of x minus 1. And the derivative of x with respect to itself is just 1. So let's see, I've got x divided by 3 x minus 1 to the 2/3 power times 1, the derivative of x minus 1, plus x minus 1 to the 1/3 power. I've taken the derivative. We're trying to find what? Critical numbers. Critical numbers are where what happens? Slope is 0, or slope being first derivative, we know. If first derivative is 0 or first derivative is undefined. Okay, so the second thing is, let's do the setting it equal to 0. So I have 0 equals x divided by this. Now we can convert any time back to the cube root if you like. Okay, anytime you want to, we can do that. I see a couple of things we can do. Give me one suggestion. Katie, what are you thinking? If your life depended on it, how would you solve for x? I think Phil's going to help you with something.
Well, this is a guess, but don't multiply both sides by the denominator of itself. So multiply both sides by 3x.
Okay, so if I multiply both sides by that, this side's going to stay 0. If I multiply this side by x minus 1 to the 2/3, you said?
Yeah, over itself. So the denominator cancels for
But over here, what am I going to end up with? Multiply both sides, I'm going to have to multiply this one also. Yeah. It's a good start. It's a good start. Okay, keep thinking about it. But it's to the 2/3 power. What's the order of operations say? So do what now? You mean to tell me you were going to tell me you wanted me to do something like take the cube root of, I'll make it the square root of 9 minus, whoops, I don't want to do that.
I don't know.
25 minus 9, and you wanted me to say that that's the square root of 25 minus the square root of 9, something like that? Want to do it with cube roots instead? Would it work? This is, I think, the square root of 16, right? Which is the same thing as 4. This is 5 minus 3. Well, you tell me. Is it going to work? The answer is no. Okay, I'll take that answer. Okay. You cannot distribute when you're dealing with an exponent. Okay. Some other good suggestions. Maybe I write one now. Good suggestions are good, whether they're right or wrong. Okay, so what do you think? Aaron? Yeah, you got a choice there. Go ahead. Aaron Austin. While she's doing that, Stephanie, would you close that blind? I got a glare of a car. Yeah, that one right there. Glare of a car. Don't we love the sun? Okay, go ahead, Aaron. Thank you. Okay. Well, I don't know what you're going to do, but let me just kind of play around with this a little bit. Anything illegal with that? No? If I do that, what can I do next? Okay, so now I'm kind of getting back to what Phil said, aren't I?
Yeah.
Except that I'm multiplying everything by it. Okay, but it's basically the idea. Okay, so now I've got x minus 1, I've got x minus 1 to the 2/3 power, so I think I've got negative 3 times x minus 1 to what power? Good. 1 is 3/3. 3/3 plus 2/3 is 5/3. Is that going to help me any? Where am I going on this problem? What do you think? You know what? Yeah, I mean, we're going to make it there, but let me give you, I just saw my notes, I saw, this would make it a whole lot easier. What if, and no one gave me the suggestion, but what if we write this as one fraction? Would that make it easier? Stephanie, just got to speak up faster. You're nodding your head, right? You thought about that? Yeah, give yourself credit. Okay, so Stephanie's going to help me now. She's back there. She sees it already. So Stephanie, take it. Okay. So it's, again, back to what Phil was saying, more or less, kind of.
So you multiply the x plus 1 to the 1/3 by the nearest fraction.
And place it all over. Okay. So I don't like this piece. Not that we couldn't finish it up. If you've got it on your paper, keep it there. You can do that. It's just not where I want to go with this today. Okay, so now I've got this. I've got 0 equals x plus 3, the quantity x minus 1. There, here we go again. Well, except it's just that, isn't it? Divided by. Phil, were you getting this?
What's that?
Did you get this? You were telling us how to, we were going to kind of use your idea, and then
I was trying to.
I know, and then I told you no, didn't I? That's my fault. Okay. I take the blame. Okay, let's see here. Okay. So now what? And is this right? Okay, so now what? Our numerator is now, I got 4x minus 3. How about you guys? Okay. So now that you've got a fraction whose value is 0, now what do you know? Say it again. Don't check your arithmetic out the door. If you've got a fraction whose value is 0, which part of the fraction is the only part that can give you a 0 value? The numerator. Now, if you didn't think about that, well, maybe you thought about multiplying both sides by this. Okay, that would still give us that 0 equals 4x minus 3. You like this? It's getting easier? Looking good? X equals what? 3/4 or 4/3? 3/4. Okay. Whew. So what? What do I have? What does this tell me? Yes, go back. We're trying to find critical numbers. What good are critical numbers? I use CN for critical number. You may use it also. I'll know what that means. It's a critical number. Therefore, what? We know that the slope of the tangent line at that point is 0. Okay. What else do we know? On either side? Okay, so now we need to go search for, is it increasing or decreasing on the left side, the less than side? Well, here we go. Here's my 3/4. That's on a number line. Okay, so I've got my, my intervals I have to talk about. If I'm going to divide my number line, split it at 3/4, I have an interval of negative infinity to 3/4. And the other one is 3/4 to infinity. Okay. I need a test value. Is that an input or output value? Input. Okay, let me make sure. Did I skip a step here? Nope, test value. Next thing we did. Okay, so a test value. What are you going to test? Give me an easy, it's late in the day. Give me an easy value to test. Oh, give me something easier. 0. I like that. Wouldn't 0 be easy to test? Where's my derivative? Where do we end up? Right here? My derivative. If I put 0 in there, I can really tell you what that's going to equal. So that's easy enough. Okay, what's another test value that would be easy to do? 1. Okay, don't have to be very far away from that value. Okay, so now what's the next step? Sign of what? Derivative or the function? Derivative. Okay, so if I go back up to my derivative and I put 0 in here, I have negative 1 cubed, and then I square it. Negative 1 squared is how much? It's positive, right? Cube root of that is, but I'm going to put 0 up here, so what does it matter? Right? This thing is 0, as far as I'm concerned. I'll put 0 in for x. You with me? Okay. Over here then, 0 minus 1 is negative 1. Negative 1, the cube root of negative 1 is negative. I only need to know what that's negative. So the first derivative is negative. What's my conclusion? F of x is decreasing. Okay, now I've got to put in 1. Go back up to your function. 1 minus 1. Uh-oh. Can I use 1? Did we test that out? We only tested to see if the derivative was 0. What else happens at critical numbers? Undefined. If I put 1 into this derivative, what happens? Undefined. I can't do that. So I'm going to have to alter this a little bit. And instead of saying from 3/4 to infinity, I better make it to 1. And I better not use 1 over here because that makes it undefined. I better make it instead, oh, I don't know. What should we make that? 9/10 or something like that? 7/8, whatever you want it to do. And we're going to have to say 1 to infinity. Now, in order to make sure we get through this problem, I'm going to just say, let's go to our graph. Thank you.